Hello, welcome to A-Level Physics and Mathematics. In this episode, we are going to break down angular momentum of an object or a particle, you can say a system, okay? I believe you are familiar with linear momentum as well as the conservation of linear momentum. If you are not familiar with that or just linear momentum as well as the conservation of linear momentum, please let me know in the comment section. I will do another episode regarding with the linear momentum as well as the conservation of linear momentum. So, like I said, in this topic or in this episode, we are going to talk about or we are going to break down angular momentum of a particle or a system. You can say body, okay? So, before that, could you please like, share, and subscribe this episode? If you are in TikTok, could you please like, follow, and share with your friends? So let's proceed with the today's topic. So like I said, angular momentum, we are going to talk about angular momentum. So angular momentum is basically the rotational counterpart of a linear momentum. You can define the angular momentum is the rotational counterpart of the linear momentum, or in a simple term you can define that mass in rotational motion is called angular momentum. Okay, mass in rotational motion is called an angular momentum. Let's say there is a kind of particle of an object, or we can say an object or a particle is rotating in the axis of rotation. Then the momentum, basically you can find out the momentum. You can symbolize or you can use this small l with arrow to represent the angular momentum. So meaning that what I'm trying to say is angular momentum, you can find out the angular momentum is equal to, based on the definition, you can find out multiply the position vector with the angular the linear momentum. This momentum. Okay, from the linear, as you know, from the linear, from the linear momentum definition, you know that the linear momentum is equal to with a mass multiplied with a velocity, right? Now, you can plug this term or this term, basically this parameter in this or in terms of what? In terms of a linear momentum. Therefore, you can calculate that, or you can get a angular momentum is equal to with a position vector multiplied with a mass time with a velocity, meaning that you can represent this guy look like this. Okay, mass, open the bracket, a position vector multiplied with a velocity. Okay, this is how you can calculate a angular momentum of an object or a particle. Okay, technically this equation is equal to with inertia multiplied with angular velocity, right? So this is basically, like I said, the same as with this equation. So to just let you know that as you know that from inertia is equal to, basically is, the inertia of an object is equal to, you can find out the inertia is equal to, or what I'm trying to say is, let me write over here. So let's say angular velocity is equal to velocity over r, right? And I just want to let you know that velocity is equal to, is what? Velocity is equal, velocity is the equivalent, rotational equivalent of angular velocity, as well as mass is rotational equivalent of inertia. Okay, I just want to, this is equivalent, basically. What I'm trying to say is velocity of an object is equivalent, rotational equivalent with the angular velocity, as well as mass is rotational equivalent with the inertia. Okay, using this relationship, basically you can calculate the angular velocity using this formula, as well as when when the axis of rotation is perpendicular to the axis of rotation, you can find out the moment of inertia is equal to using mass time with r square, right? ይህን በባለፈው ክላስ ዲስከስ አድርገናል። if you don't የባለፈውን ክላስ ኤፒሶድ ቼክ ካላደረጋችሁ እሱን ኤፒሶድ ቼክ ማድረግ ትችላላችሁ ማለት ነው። so then moment of inertia is equal to, like I said, moment of inertia. When an object is perpendicular to the axis of rotation, you can find out the moment of inertia using this relationship, or you're using this equation. And also you can find out this is basically an angular momentum as well. You can represent by L as well as capital L, which is vector quantity, okay, which is equal to moment of inertia multiplied with angular velocity, right? Now, I just want to drive this equation over here using this relationship. So, moment of inertia is equal to, like I said, you can calculate this relationship, okay? Now, this moment of inertia is equal to, like I said, if an object is, I mean, like this XYZ plane, if an object or if the particle, I mean, the axis of rotation is perpendicular to the if the axis of rotation is perpendicular, then the axis of rotation is perpendicular to the center, or if you can calculate that, the moment of inertia using mass time the radius, which is r. So what you can do is, like I said, you can plug this guy over here, okay, meaning that mass multiplied with r square multiplied with omega, okay, this is omega. Then from this relationship that omega is equal to, you can plug this guy over here. Therefore, angular momentum is equal to mass multiplied with r square multiplied with r, I mean v over r, right? V over r, okay? Now you can cancel this guy with this guy. Therefore, angular momentum is equal to, you will get that mass multiplied with r. Basically, in our case, you can use a position vector, okay? Now, multiplied with velocity. That is it. Basically, you can use this r over here since they are a vector quantity, okay? This is, like I said, this exactly the same with this relationship. You can use a bracket over here. So that is, like I said, the same with this relationship. And then you can also find out the magnitude of the angular momentum using this relationship. Well, L is equal to r, or position vector, multiplied with mass multiplied with velocity time with the sine of phi, okay? You can use you can use a theta in terms of phi. I'm using this phi, okay? In terms of this phi, you can use any angle representation. Normally, we can use phi or theta. This is how you can calculate the magnitude of angular velocity of a particle or an object. And one last thing I just want to let you know, from this relationship, I believe you can find out the SI unit or standard unit of this angular velocity. So this is represented by kg, right? Which is mass, I mean, the SI unit of mass is kilogram, as well as the position vector can be represented by m, as well as this guy is m over s, right? Which is meter per second, okay? Then you can multiply this guy over here, you will get that actually, I mean, mass time, I mean, kilogram, m square upon what? M square upon, I mean, m square per second, which is kilogram meter square per second. That is an SI unit of angular momentum. So that's all about today. Let me know if you have any question regarding with angular momentum. I'm happy to reply to you guys. You can feel free to put your question in the comment section. Like I said, I'm happy to reply for you guys. So yeah, that's all for today. See you in the next episode. Before wrap up this session, like I said, could you please like, share, and subscribe at this channel? That will help me a lot. Yeah, see you in the next episode. Have a good day. Thank you.